Okay, today we're going to talk about the centroid and the orthocenters of circles. So the first one we're going to talk about is the centroid. And you find the centroid by constructing the medians of a circle. So how you do that, you've got a triangle. And to find the median, you take these 2 points, and then you use your construction. You can use a compass. You're going to put marks there and marks there from these 2 points. You're going to put your compass like this. This should always be the same distance, okay? Don't adjust. And then you draw a line through it. That gives you the midpoint. Then you take the midpoint and you draw a line from the midpoint to the opposite vertex, okay? So that is what you're going to be doing for each one of these. So you would, again, construct a midpoint, then draw the line, construct the midpoint, and you'd have to be doing the midpoint for each one of these, and then connect. And that gives you the median. So you can see these blue lines here are the actual medians. They are not the midpoints of the side, okay? So these are the actual medians. Where the medians intersect is called the centroid. Now, what's special about the centroid? It is 2/3 of the distance from each vertex to the midpoint of the opposite side. So you look at this and you go, okay, this is the shorter side, so this is 1/3, and this is 2/3. Okay, this is the short side, so this is 1/3, this is 2/3. So you do have to pay attention. There will always be a 1/3 and a 2/3. So make sure you're looking at which is the longer and which is the shorter. So that's telling you that if you look at this, AP, that's the distance from here to here, is 2/3 of the whole thing, AE. And PE is the short side, that's the 1/3 of the whole thing. So it's giving you all of those definitions and all of those measurements. So push pause and look that over to make sure you understand. Now let's do a couple of problems. Okay, so using the centroid of a triangle, in this one we can see that point Q is the centroid. Since we can see that this line is going to the vertex, we know that this is a median. And we know by definition that one part is 2/3 and one part is 1/3. Since this is SQ is the longer portion, we're going to say that it's the 2/3 and QW is the 1/3. So we're going to go SQ is 2/3 of SW. Then we're going to substitute 8 for SQ. Then to get rid of the fraction, we're going to multiply by the reciprocal on both sides. Those cancel each other. And then we cross cancel. 2 goes in 8 4 times. 3 times 4 is 12. And that gives us the measurement of SW. Since SW equals SQ plus QW, then all we have to do is go 12 equals 8 plus QW, and that means QW equals 4. And those were the measurements that they asked us to find. Okay, so P is the centroid of LMN. QN, that's the whole big line here, is 45. They want you to find PN and QP. So I can tell you that this one is the 2/3 and this one is the 1/3. So you could do it really easy and say 45 divided by 3 equals QP. Or you could say 1/3 of 45, it's the same thing. So that means that QP is 15. Okay, or you could say 45 times 2/3 equals PN. 3 goes into 45 15 times, so 30 equals PN. Then you could double check by adding the two, and they do add up to 45. So there you go. Okay, so looking at these are the points of currency of the 3 medians. So you can see that the acute is on the inside, an obtuse median is on the outside, and a right is on the hypotenuse, and an equilateral looks like all the others, it's in the middle. Now the thing I want you to notice is that these dotted lines are the construction lines. These are the construction that was done to find the midpoints. Okay, and once they found the midpoint, then they connected it to the opposite vertex to get the median. Okay, so make sure you're understanding what these lines are. Whenever you see these kind of things, that means that somebody constructed it. Okay, so now we're going to talk about the orthocenter, but we first have to learn what an altitude is. An altitude of a triangle is the perpendicular segment from the vertex to the opposite side of the line that contains the opposite side. So here's the altitude here to this line, and this is the altitude from Q on this triangle. Notice I had to go outside the triangle, so you have to be careful. Okay, so remember, you can use any side of the triangle for the base. The height is the length of the altitude from the base to the opposite side, but it has to be a perpendicular measurement. Okay, there you go. So, the orthocenter is the lines containing the altitude of a triangle that are concurrent. The point of concurrency is the orthocenter of the triangle. The lines containing AF, BD, and CE meet at the orthocenter. So each one of these lines is an altitude. Notice it is coming from a vertex, going to the other side of the triangle, and it's perpendicular to the side. And then where each of those meets is the orthocenter, where they all meet. Okay, so the location of the orthocenter, P of a triangle, depends on the type of triangle. So with an acute triangle, like the one they showed in the proof, is inside the triangle. On a right triangle, it's right there. It's on the triangle. And an obtuse triangle, it's going to be outside because you have to construct them to extensions of the line. And we'll go over that in a little bit. Okay, so the altitudes are shown in red. Notice that in the right triangle, the legs are also altitudes. Because you're going from the vertex down to the side. And there's my side that I'm going to, and that happens for each of these. So they're both right angles. The altitudes of the obtuse triangle are extended to find the orthocenter. In other words, to find a perpendicular line, you had to extend this line out here, and then you put the perpendicular line to it. So that's what's different about an obtuse triangle. Okay, so one more time, I'm just going to go through the constructions that are required to make each of these segments and lines in the triangle. So the first one we're going to use to find the circumcenter is the perpendicular bisector. So you have your triangle, and you're going to take the two endpoints, and you're going to make arcs. Same distance from both sides. Arc here, arc below, and then where they intersect will be the perpendicular bisector. And if you do it correctly, these will be equal. Okay? The angle bisector, you take a triangle, and this is used to find the incenter. You make an arc, and then from the arc, you're going to use your compass, same distance on both, and you're going to make arcs like this. Then you're going to extend it from the vertex through there. And that would be an angle bisector, which makes both of these the same. Okay, the median we just discussed. The median is where, again, you're going to do the same thing you did with the first one, but once you've got that midpoint, where these are the same, then you're going to draw a line from there. Okay, it's not always going to be perfect, so if I did this one, this might be my median, and I would connect it over here. Okay, and finally the altitude, like I said, you take this line, you make an arc like this, then you take these 2 points and you make an arc and cross the compasses, same distance, and then you go like that, and that will be the altitude. And it has to go through this point. That's why you have to make this line first. And that will put this point in the center of the arc, and then when you make your tags up here and down here, it will put it right through the vertex and make it perpendicular to the base. So study these a little bit more, and you will understand them a little bit better. Have a good day.